So what's a little bit different about this one, of course, is that we have the equation instead of a graph, right? So we want to, if we have this quadratic here, we want to find the rate of change on the interval 2, 4. And so first thing we need to do is figure out, okay, well, what is f of 2? And so we've got 2 times 4, which is 8, minus 6 plus 5, so that's going to be 7. So now we know one of the points on the graph, 2, 7. And then we need to do the same thing with f of 4. So 2 times 4 squared, which is 16, minus 3 times 4, which is 12, plus 5. So 32 minus 12 is 20, plus 5, so 25. And so we've got the point 4, 25. And so, of course, our rate of change, we are going to have, let's see, 25 minus 7 over 4 minus 2. So we're looking at 18 over 2, which is 9. Okay, so don't make these harder than they are. I'm going to say that a lot. Now, this one's a little bit weird because now we're doing the interval from x to x plus h. So on our x-axis, so we've got 0, x could be anywhere, right? And now we're saying just a little bit over from x is our point x plus h. So we can think of that, let's see here. So we can say that the distance between these two, of course, is going to be h. But, so we've got here, we're going to say, okay, we're going to say what is, first off, what's f of x, right? Because we're going to just do the same things. Of course, f of x is 2x squared minus 3x plus 5. That's easy enough. Now, f of x plus h is going to be a little bit of a mess. So f of x plus h. So everywhere we've got an x, we're plugging in x plus h. So we've got 2x squared, so 2 times x plus h squared, minus 3 times x plus h, plus 5. And we've got to go multiply everything out. So that is going to be x plus h squared. We've got 2x squared plus 2xh plus h squared. I'm going to go ahead and distribute the minus 3, so minus 3x minus 3h plus 5. So we've got 2x squared plus 4xh plus 2h squared minus 3x minus 3h plus 5. That is a mess, but it's necessary. Okay, so we've got y values, outputs, f of x, and we've got our inputs. So we're going to remember that our rate of change is our f of x2 minus f of x1 over x2 minus x1, right? But in this case, we've really got f of x plus h, because that's our x2 minus f of x over x plus h minus x, which of course will simplify just down to h. Okay, so we've got a little bit of calculating to do here. And I'm going to do a little trick here. So we have f of x plus h, we've got that all figured out. We need to calculate f of x plus h minus f of x. And we had f of x here. So we had 2x squared minus 3x plus 5. So we're going to subtract these, just don't have to rewrite things over and over. And of course, the x squared terms are going to cancel. So those are going to cancel. I'm going to have the 4xh. I'm going to have the 2h squareds. I'm going to have my 3x terms are going to cancel. I've got 3h, and my 5s are canceling, because remember, we're doing subtraction. Okay. So, what do we have now? So we've got 4xh plus 2h squared minus 3h all over h. And yes, we can simplify that, because that's really 3 fractions, right? So we've got 4xh over h, so that'll just be 4x. I've got 2h squared over h, so that'll just be 2h. And I've got a minus 3h over h, so that'll be a minus 3. And we finally arrived at our difference quotient. Now in calculus, we're going to say, okay, what's the value of this? As h gets really small, this is going to become what's called an instantaneous rate of change, which is also known as the derivative, which in this case would be 4x minus 3. So, and if you are in calculus now along with this class, you probably know how to do derivatives by now. And if you do that real quick, you'll see, oh yeah, it's 4x minus 3. So this is, we're going to have to stop here. This problem took a little bit of time.